Good morning everyone. Welcome to CATIA Technologies. Today in this video we'll be seeing a part of a air compressor and how do you make it. Air compressor is basically a large assembly. We have taken a very simple and a small part to understand the internal features and how to make these kind of slanted cuts, etc. So let's begin. The section view is actually cut at this location, so you can see the internal cuts and the internal holes features as well. Now on the top you can see that there are radial holes on the diameters, circular cylindrical diameter cylindrical features. So let us see how to make this model by maintaining the exact dimensions and not deviating from it and exactly getting the shape of the model. Now since we can see that it's a part modeling exercise, it's a very simple part module. Under start you have mechanical design, you have part design. This actually comes under advanced part modeling, wherein you have few features which you will generally not be using in the beginning of your training. These features are used towards the mid section of your trainings. So let's begin. Now since we already know that all of these are diameters, as you can see, we'll try to control the dimensions first and then try to control the cuts later. So I have 34 and I have 12 which I'm supposed to maintain. So under the shaft command I'd like to make that first and then proceed further. So what my point is to make for me is to maintain the dimensions. So to maintain the dimensions, all I have to do is take a simple rectangle. We do know that the overall dimension is 34. I'll just take it from here to here is 34. And the dimension towards the bottom is 12. This is 12 as you can see. I am considering this location as my 0, 0. Later I can add the 18 and start cutting it. While doing so, we have a diameter as well. So the diametrical diameter for the overall component is 340. I'll follow a feature based approach wherein we have to remove the model, all the material one step after the other. We cannot directly remove it in one go. It should be done in a way it is done in your real manufacturing unit. This is your first cylinder. Now on this face on the top also you can see there's another cylinder at 54. So let's try to use another shaft command. You can of course use pad as well, there's no issue in it, but there will be a difficulty in maintaining the dimensions. So I'd prefer using shaft over pad command. This is a rectangle. Now the height is from 54 from here, so which we already know this is supposed to be 54, and the diameter is 120. So from here I'd like to take the diameter as 120. Exit, you can see the cylinder. Now we can start removing the material one after the other and add if necessary. Now as you can see in the drawing, this seems to be like a support, as in like a stiffener. But actually there is no material here. If there is any material here, you will be able to see hatching. But there is no material here, but there is material throughout the other area. So to understand that, since there is no hatching, there is a slant cut inside a cylindrical shape. The shape actually looks like this. Let me try to make it for you. This is my reference. Similarly, this is also my reference. Now let me try to make the shape for you. It looks somewhat like this. We know the end diameter as well. So let's try to give the end diameter, that is this. You know this diameter, which is actually 220. And this is supposed to be starting at a distance of 6. So I'd like to give that as 6. Now this should be closed, of course, because we are in your shaft command. Let us try to close this. And once we exit, it tries to create the shaft with respect to your center. This is actually how it looks like. These are the cuts which are formed on this shape. So you can see that there is no material here and there is material throughout the other side of your cylindrical shape. Now let's try to remove these. Since we have already seen how to remove, I'm trying to use a group command one after the other. I have the same reference as the axis, and I'll be using these two as my references because I need them. Now, we do know that the 18 is supposed to be cut from this side. This is the shape which is supposed to be cut. So let me try to take that first and then go down till here, and of course the remaining portion should be cut till 12, which we have already taken it as the reference earlier. So we do have the 18 now and the 12. The left dimensions are your diameters. So for this is supposed to be 260. So let's try to take 260, and you can also have 120. Now once I exit, it tries to remove the material this way. This is your cuts. Similarly, there are holes as well inside, as you can see. I'd prefer doing a cylindrical cut inside using my group command, so I'd like to do that. You can also use multiple holes, but again my preference is to maintain the dimensions rather than controlling the commands. And of course I have the center. Now let's try to maintain the dimensions and make this shape. We do know that there is 66 from here to here, and then goes a little big this way, which is 88, and then goes small, which is 56. That is around 6 distance. So firstly, let's try to give these dimensions and then slowly go ahead and give the other ones. This is supposed to be 56. And this diameter is supposed to be 88, of course. And the down one is supposed to be 66. Is it all in your in the drawing? This is 66, this is 56, this is 88. Now we have 6 and 9 as the distances. So the distance from here to here is actually supposed to be 6. Similarly, the distance of this one is actually supposed to be 9. This is your constraint sketch. Now once I exit, it removes the material off of the body from the inner side. You can also see the dynamic sectioning and also give it a go. You can see how it looks like from the inside. Now we do have few cuts which are supposed to be done. As you can see, this is the slant cut and this is another cut. So let's try to do those two. Before that, I'd like to make a sketch for the cut rather than proceeding further without references. So for me, the actual references is the bottom face of this. I have taken that as my reference as of now. Similarly, I would require a round before proceeding with this. So let me try to exit. Over here, I'll just give a round before proceeding further. There's a round here, which is actually of 12. Both are dependent on the round, so I can use that too. Now, while working on this, I have my references. And this is another reference which I'd like to use, of course, in the construction format. Now let's try to take the profile. As you can see, the profile starts from here and ends over here. This is your actual profile. We know the dimensions of this, which is from here to here, is actually 106. It's at an angle of 106. Similarly, you do know the distance from the top to the center point, which is supposed to be 6. This is your constrained profile. Now, to remove material in a standard slanted way, you can use either your pocket or you can use your slot. I would prefer to use slot because it's a slanted cut, it's easier to remove. To make a slot, first we require a profile and then a path. We have already given the path, so let's try to sketch a profile which follows that particular path, which is which is following throughout the path. This is my circle, so let me try to take that as 4 dia and exit. Now this should be cut through the body following the sketch. This is my profile, this is the center curve. Make sure it is cutting through the curve. If it does not, use merge slot ends, it cuts through the body. You can again go back into your dynamic sectioning to see how it looks like. You can see the slant cut. Similarly, you have another one onto the opposite side as well. You can pretty much do the same thing and go. I'm using my references at the moment. Similarly, I have the top face. It's stopping at the top face, so the top face is another reference of mine. Now I can simply make a sketch from here to here. This is actually in line with the inner circle. So let's try to coincide this onto that and then start giving a dimension, which is the angle. Now, there is an angle also. There is an angle also provided for us. The angle is actually 35, so let's try to take that as 30. Let's try to take that 35 as well and constrain the profile. I'll try to constrain the reference as well, just in case it's not taking the shape exactly as I want it to. Okay, this is your 35. Now once I exit, you'll be able to see the sketch. I'll be following the simple same concept, which is your slot, but provided I'd require a plane first. So I'm taking a plane and sketching the profile, which is supposed to be following the path. Now I have a reference again over here, so I'm using that reference and then I'm trying to make the sketch. The sketch here is 8 dia circle, which is following throughout the path. So I have an 8 dia circle here. And to remove the material, I'll be using slot. While creating the slot, it will ask for a center curve. Again, make sure it is cutting off through the body here and say okay, it cuts off through the. You can now use your dynamic sectioning to again check if it's correct or not, and you can see that there are 2 slanted holes which are actually being cut using our slot command. This is the most important command for this particular model. Now, since you have understood this, of course, it's easy to remove this shape as well. So let me try to take this space and use pocket, which is easier for us to create a cut using this as my reference and this as my reference. I'd like to remove the material now. There is one sketch here and mirror the same thing onto the other side with respect to the center plane. Maintain and close them, of course. I'll use the center to close them. Now the distance between these two is actually given as 16. It's typical, that means it's the same for all the 4 sides. And when I exit, you can start removing the material. The material should be cut towards the other direction up to the next surface it can find, and you will be seeing the cut. This is how actually looks like. You can again check your dynamic sectioning view and also see how it looks like. You can see the slant cut. Here you will obviously not be able to see the material. This is how it is supposed to look like. Similarly, I'd like to create the pattern for this. So I'm using a simple circular pattern. It has a complete crown of 4 and the pocket. The reference element will be your z-axis. You can select z-axis here as well. You can see the cuts. There are multiple holes as well which are created over here as well as over here. So let's start with the inner one. It's on 100 PCD. So when I take a hole, I can actually make a sketch inside and then work on it. So let me try to do that. I'll just put this aside for a bit. And I'm taking a circle and saying it has to be at 100 PCD. So let's try to dimension that and give it as 100 PCD. Now on this, it has to maintain the hole has to be done on the circle. So I'm just trying to coincide this on the circle. Similarly, I'm trying to coincide this on the center. When you exit, you can see the point there. This is your actual location. And how much is the dia? You can see that it is at 14. And okay, I think it's at 45 degrees. I'm so sorry, I took it at the wrong location. It was supposed to be at 45 degrees. So let me just change it to 45 degrees. Actually, you can use a bisecting plane as well. That would have been a little more easier. But okay. This on the line. Side, and this should be coincident on the line. Once I exit, again let's come back. 14 dia and you have 4. They are actually up to the next surface it can find, which is there. They're not going through. That means they're just going till a certain extent. They're not going through. Yes, they're going till the next surface it can find. That is only till here. So I'll just try to select there and then stop it so you can see the feature there, and then say okay, this is your feature. Now it can be cut on 4 sides. Again, similar circular pattern you can use. You require 4 90 degrees perfect in the form of Z axis, and you'll see 4 more. Similarly, you do have another one over here on this. So let me try to take the feature here. Even that has a PCD of 300. So let's try to take the PCD first of 300. And then I'll try to maintain concentricity first instead. This is supposed to be 300. Now let's try to coincide this on the circle. Anywhere, whichever you're comfortable, you can. Even if you think this is your right this thing, you can coincide. We do know the diameter, which is 17 and is through. So I'm taking it as 17 and I'm saying it's through. You can again give the circular dimension here, but there are 8. So let's try to give 8. And then with respect to the Z axis, it's supposed to be complete crown. You can see this. Again, if you want, you can check your dynamic sectioning view. You can see how it looks like. I'll just show you the front view. This is how it actually looks like. You can see the front view now. This is your feature. This is how you work on when you have slanted cuts, etc. If you're looking for a little more complicated level of training, you can join us. Please subscribe to our channel for further more videos like these. We'll keep posting you more complex videos as well, tutorials as well. Thank you.